So now we are on the last one, guys. So we've graphed out, we've made tables. We've dealt with example 3 where we made tables, and before we made tables where it was a little different when it came to the domains or the restrictions or conditions or intervals. So this time we're actually going to put it all together. So with it, we're going to make tables first, and then we're going to go ahead and talk about how everything is going to graph out from those tables. So we're going to fly through the tables because we've done that already. We've done like 2 examples of it, just focusing on the tables itself. All right. So here, we have 3 tables because there's 3 functions. So the first table is going to be x plus 3. All right, our second table, we have x here, and then we have 3 minus x. And then for our last table, third table, because again, remember there's 3 equations here, so there's 3 tables. To x, and then 3x is the equation. Right. Again, looking back at our intervals here, looking at this part here, it says x is less than or equal to 0. So again, if you need that number line real quick, get 0 going on here. We shade everything on this side. So all the numbers that are less than 0 go there. So we start with 0, do -1, -2, -3, and I'm going to go to 5 using 5 numbers. So -4 is the last one there. Here, if I put 0 in, that gives me 3. -1, that gives me 2. So -2 plus 3 is -1. Sorry, +1. Sorry, my fault. -3 plus 3 is 0. -4 plus 3 is -1. So that's where -1 is. All right. For our second one here, we know it's going to go from 1 to 3. So 1, 2, 3. Because it says starts at 1, ends at 3. Right. And then our last one here says it's greater than 3. Shade all these numbers right here. Parentheses there because it doesn't have an equal to sign. So here we start at 3, and all the numbers that are bigger, so 4, 5, 6, 7, so on and so forth. So on and so forth. So we did that part. All right, but I didn't actually fill that in. Oops, let's go back and fill that in, guys. So here, 3 minus 1, 3 minus 1 is 2. 3 minus 2 is 1. 3 minus 3 is 0. All right, and you can put that in Desmos if you want to, but it's too easy to put it in Desmos. For me, it is. All right, so 3 times 3 is 9, and I'm a math teacher, so if you need to put Desmos, put it in Desmos. Find these values. Make sure they're accurate. All right, 3 times 4 is 12. 3 times 5, 15. 3 times 6 is 18. 3 times 7 is 21. 21. 21. All right, again, pulling in the conditions there, the restrictions, domain, intervals, whichever one it's called at that moment. Pull this one in. Pull this one in. I'm going to pull this one in. All right, so we got that. We got those down. So now we got to figure out, okay, are they open or closed circles? Inquiring minds want to know. All right, so, back up. All right, back up. All right. So here, this says less than or equal to, so it means it's a closed circle. Here we have an inequality and another inequality. The first one doesn't have an equal to sign, so it's open. So 1 is an open circle. Here, this is a closed circle because there's an equal to sign there. And then here, another one's just a greater than symbol, which is open. because it does not have the equal to sign. So here we see for the first one here, this is a closed circle. This is open for 1, closed for 3. This is open for 3. And then hopefully you guys remember what we said about the other ones. Remember all the other points are closed circles. So if they're not these right here, the endpoints, they're closed. So we close you, closed here, and 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 closed here. And close. Oh yes, we did. We just closed here, just closed it there, and closed it here, and we closed it there. So if it's not one of these endpoints here from your condition or your domain, your interval, your restriction, it's closed. If it's not one of those here, it's closed. All right, so we're good. We got it. We got the table going on. All of our tables. So now we've done that. We've spent time on graphing the table, well, making the tables. All right, the last part now is the graphing portion, where we're going to graph out these tables that we just created. So here, I'm going to pull this up here. And what's going to always happen here for our class, I'm going to go in 10 in all directions. So 10 up, 10 down, left and right. We're going to go 10. So when I graph here, that's what we're going to do. Cool. So I'm going to come here. I'm going to do this. I feel like I'm wasting time. So I'm going to pause this and I'm going to come back and actually have the full graph. Ooh, I jumped ahead. Oh, all right. So here we're labeling it. And again, remember, you have to label this. Assume that, like for example, like I'm stupid or something. And I don't know what you're talking about. If you don't put the label these here, I don't know what numbers you're looking at, what you're graphing. All I know is there's a table. All I know there's dots on the graph. And I don't know if it's the right dots or they're wrong dots. I don't know. So I would have to mark it wrong because I just don't know. So label your graph here. Make sure you label in all directions because we're going to be using all directions here. All right. Oh gosh, it shouldn't do purple. Oh man, whatever. It's already too late. All right. So again, like I said, we're going to color coordinate everything. So our first table here, right here, is going to be graphed on here in purple. Which I shouldn't have made the graph purple. But oh well, it's too late now. All right, so at 0, 3, so 0, 3, so we're not going left, right, just going up 3, is a closed circle. At -1, 2, it's a closed one. -2, 1, closed. 3, -3, 0, closed. -4, -1, closed. All right. And before we actually do any type of connection going on, we're going to pull in the inequality one more time, that condition. If you remember back on the number line that we had up here, we know we had negative infinity on this side, positive infinity. If we were to write this in interval notation, it would be from negative infinity to 0. We have a bracket here and a parenthesis here. We start at negative infinity, end at 0. All right. With that, infinity means an arrow. So when we graph this out, it starts at 0. Graph it out. It has an arrow on it because it has infinity. So we put an arrow on the end of it because of infinity. All right, going to the next graph. We go from 1 up to, oh, sorry, it should be an open circle there. Open circle, 1, 2, a 2, 1, then a 3, 0. So open circle that 1, 2, which we have right there. All right, have an open circle there. All right, and then our last one, really quick back. We're going to plot this out. And actually, let me do this real quick too. So this one, it says between 1 and 3. Interval notation means to be +1 and 3 with a bracket. Open circle for the parenthesis and close circle for the bracket. Remember, we remember that. We remember. All right, and then the last one, we have the last table, which is 3, 9. So 3, 9 right here through the open circle. After that, we have 4, 12. 4, 12 goes well above the actual graph, that 10. So if it goes past 10 for my class, all I'm going to have you do is just draw an arrow. This is going to go above the 10 that we have set. And we're going to go in 10 all directions no matter what. That's our thing. All right, so just really quick looking at the inequality here, the condition. We know here, looking at the graph too, that starts at 3 and it ends at positive infinity. Again, since we have infinity, so it starts at 3, positive infinity. And because we have infinity, remember infinity means an arrow. All right, so infinity means an arrow. And guys, that's our piecewise function. That's our graph there. So that's it. We did the tables, talk about open and closed circles, and then we just graphed it out on a number line. On the graph, sorry, not number line, but graph. But again, remember, all of these functions or equations must go on the same graph. Not on 3 different graphs, all on the same graph. All right, that's it, guys.